Good night. Today we're going to present our Nintendo project. My name is Alejandro Cárdenas Jauregui. He is.
Soy Ganesh Estrada.
And we're going to proceed to our problem, that is pattern recognition.
Well, the problem that we encountered and that also serves as the foundation of our project was that in game development, there are tons of actions that a player can do, but there exists a limitation in the amount of inputs a device has. So, because if you only have a limited amount of inputs, there are only less where there is a less variety of actions. So therefore, you would need to examine a sequence of inputs in order to detect patterns that are pre-established in order to, well, that create an action.
The problem background that we have is the problem at hand is the pattern recognition. There are many types of pattern recognition, of pattern problems. Sorry. One of them can be Morse code. It has been applied. It's a pattern of dots and dashes that we recognize the pattern and we can transform them from dots and dashes to words. The same can happen in multiple industries, but that is our problem background. Programming is essential to solve this problem since it allows us to create algorithms that analyze and detect patterns efficiently and accurately, way faster than we could do manually. If we have a text file, let's say, of 1,000 or 3,000, 10,000 lines of Morse code, instead of us checking dot by dot, dash by dash, we can run it through a program and that will automatically tell us what the Morse code says.
Well, the need for pattern recognition rises because of the limitations that exist in input mechanisms, because they have a finite number of keys, buttons, whatever that I described earlier. One example of this could be keyboards that come with a fixed number of keys that are limited by the physical design of the device. So, for example, a standard QWERTY keyboard comes with 100 keys that includes letters, characters, and some control keys. Another example can be game controllers, and these are more limited since they are made to be, well, they need to be, well, they're made for the game, so you need to, well, immersive. They have an immersive experience for the user, so yeah, they use less inputs, and they come with buttons, triggers, and joysticks. So video games often involve a wide range of actions that include character movement and interacting with objects, combat, and the special abilities. And for those, there will be a need to have a separate input for each one of them.
An example of this can be like in the example of a keyboard. When we want to execute the file explorer on Windows, we can do a command or a shortcut by using Windows key and E. That can automatically open the Windows Explorer, so you don't have to do it manually. That is also a type of pattern recognition. The same goes to controllers, like in the game Street Fighter or Mortal Kombat. You could make a combo, and instead of the game executing you going down, forward, and punching, it executes a Hadouken. The stakeholders that we could have of this problem are various. The ones we have, well, the one we based our pattern problems are the video game industry. The concept of pattern recognition proves invaluable here, enabling a multitude of actions with limited button inputs. An example, as I said, is the combos in Mortal Kombat or Street Fighter. But in games like, I don't know, Call of Duty, you can use special abilities while by touching two inputs at the same time. When you do that, that is a pattern that you recognize. Another example could be another opportunity that we could have with stakeholders would be the automobile industry. Most modern vehicles come equipped with sophisticated onboard computer systems. Unfortunately, software-related issues can occasionally emerge. These software-related problems can be diagnosed and resolved by initiating a sequence of actions on the vehicle. Example that I can give here, my mom has a Nissan Altima, and in the dashboard we got a problem with flickering lights on errors like the gas error and the cooling error. So we searched on the internet and we found out that the car has commands to it, like you can use a sequence of actions and it will reboot the dashboard. What we did is we pressed the pedal for 3 seconds, moved the steering wheel twice, and it automatically rebooted all the lights on the dashboard, and it didn't give us that problem anymore. Another problem that could be on stakeholders are the medical field, because most of the problems that we have can be resolved by patterns. This is also being applied now with artificial intelligence, but it's not fully developed. We're going there.
So the main features that our code has is that we will give it an input string and we have pre-established patterns that it will search for. And in return, it will give us if it found a pattern or if it didn't find one. And it will give us also what pattern it found. Our code is also versatile in the way that it works with various patterns simultaneously and can search for them in a single input. And it is also made to handle different amounts of data, so it can be scalable to both small and large data sets. And well, our objective was for it to be user-friendly and to be able to be applicable in different situations.
The data structures analysis and comparison we did is with the vectors, linked lists, and stacks that we saw in class. The advantages of using a vector can be seen in the storing of elements in contiguous memory locations, facilitating swift data storage and retrieval. However, vectors may be less suitable if our program primarily involves dynamic resizing operations. Our does, because we need not only to have a vector, if we did it with vectors, have a vector to get all the input string, but another vector to search everything in the list, the link one by one. Then the linked list, we didn't use it because it is more useful or more suitable for inserting or deleting on the middle of all the input, and we saw that we didn't need it that much. And this type is suitable when an algorithm only makes use of the last element introduced by the data structure, and since it's simpler than other data structures, it makes it easier to work with them and reading a code.
So we chose this stack because we don't need to arbitrarily search for elements inside in the middle of the stack. We only just need the top. Other thing is that we changed the size a lot of the stack. So since the stacks have simple functions to change the size, we thought that it was simpler to use stack. So well, our code also works with checking patterns in a reverse order, and since stacks work in a last in first behavior, well, we thought it was suitable. And well, we use an underlying container of a linked list since we don't really want it to be relocating memory every time we change size.
Our program complexity is of OM because it needs to search everything on the stack.
So the connection.
Yeah. We have an array that has the combos AB, LR, XYZ, and another one. I think is
XDUR. Yes.
XDUR. So at the moment we can put things. That's the input that we can receive when we are playing a game. So at the moment we hit enter, we recognize all the patterns that were input inside that. Thank you.